Welcome, ladies and gentlemen, to Integrated 2 Math. In today's episode, we will be discussing Chapter 9.2.2, which is Systems of Quadratic Equations. Now, to begin this problem, I want to start off with a little bit of a warm-up with something that you guys have seen before. So y equals 2x minus 1 and y equals x plus 2. You knew this back in Integrated 1 as a system of equations, but realistically, if you wanted to be very specific about this type of problem, this was actually known as a system of linear equations. And the reason why it was called a system of linear equations is because the two functions that you are dealing with in the context of this are both lines. And so what happens is, the way we solve this procedurally is because they're both equal to y already, we can then say that y is equal to y, or in this case, 2x minus 1 is equal to x plus 2. And then from here, we go ahead and solve. And everybody kind of knows how to do this whole substitution method or setting them equal to each other. Procedurally, everyone kind of knows how it's done, but realistically, the objective of the problem is really the most important piece of the problem here. And so x equals 3, we're not done yet. What I'm going to do is I'm going to pick whichever version of these lines is easier to plug into. My guess is the bottom one because I just have to add and that's it. So if I do y equals, not x anymore, but 3 plus 2, I will get y equals 5. So what I obtained as my answer was an x equals 3 and an x equals 5. And for some strange reason, your Integrated 1 teacher always wanted you to put these in a coordinate form. And the reason why they had you do that is because when you have more than one graph or more than one function on the same coordinate plane, what you might be interested in looking for is a point of intersection. And that is what you have found. That's why they're expressed in coordinates. This is a point of intersection between these two lines. And in fact, I'll go ahead and show this on the calculator, that way you guys can see it. So from here, I'm going to type in my two functions, 2x minus 1 and x plus 2. Whoops, did not make a new thing. There you go. Okay, so from here, we've got our two functions right here. And now I'll go ahead and analyze the graph. So again, menu, analyze graph, intersection. Lower bound means on the left side, upper bound means on the right side. 3, 5. Notice how that's what we found as our point of intersection between the two. So, now that the review is over with, we are going to up it a level. And I'm going to begin with this example. Y equals x squared plus 5x plus 8 versus y equals x plus 5. So before we even begin, because again, procedurally, I know you know how to do it. We're going to set them equal to each other, solve for x. Piece of cake. What's important to know is that this is a parabola, and this is an upward-facing line. And I don't expect anybody to show out all the scenarios, but let's talk about what types of scenarios we could have. We could have a scenario where we have a parabola, and we have a line that intersects twice. So this is a two intersection scenario. The other scenario is that we could have zero intersections, right? We could have a line that just kind of does this, and there would be no chance of the parabola and the line ever even meeting. So this is zero intersections. Now, the other scenario is one intersection. Now, how do you do one intersection with a line? Well, there's actually quite a few ways that could happen. And I'll go and change colors for each different line. But one way is you could actually just have a horizontal line going across, but that's definitely not our situation. Our line has a slope of 1. So if it was one intersection, it could actually graze the line like that, almost similar to how in the Matrix when Neo was dodging the bullets and one grazed his leg. You could have that. If the slope was negative, you could have a line that just kind of grazes and makes impact with that parabola at one spot. Now, fun fact here, when you get into AP Calculus, what I just drew, especially with the blue and the red line, that's like 2/3 of the course right there. Well, maybe 2/3, maybe a little less. But yeah, that's pretty much all you study is that one intersection scenario, and that's the bulk of at least Calculus AB. In BC, we get a little more into weird stuff. But anyway, for now, I just want you guys to know that there are 3 scenarios at play here. I don't know which one it's going to be, but the way we solve this is exactly the way we solved the last problem. I'm going to set them equal to each other. X plus 5 is equal to x squared plus 5x plus 8. And please remember that with all quadratics, we always set them equal to 0 in order to solve. So please don't attempt to subtract and then divide. That would not be a good scenario to be in. So x squared plus 4x plus 8 equals 5. I'm going to go and subtract 5 from either side. Again, I'm setting the equation equal to 0. Pardon my handwriting there. That's what it looked like, a 6. And then plus 3. And now from here, once I have it set equal to 0, now this guy is going to be factorable. So x looks like plus 3 and x plus 1 are my factors. So it looks like x equals negative 3 and negative 1. So what does this mean in the context of the problem? Well, because I got 2 x values as my answers, I feel like I'm dealing with a 2 intersection scenario, because there are 2 different values of x where this parabola will make contact with this line. So how do I find the y coordinates? Well, from here, before I do that, I'm going to say, okay, well, this is negative 3 comma something and negative 1 comma something. Again, I'm already preloading myself into that coordinate form. And the way I find that comma something is I plug it in, just like I did last time in the linear systems. I'm going to figure out which one is easier for me to plug it into, and then I'll plug it into there. Now, I think it's a no-brainer, but I'm going to go for the bottom one. So y equals x plus 5. I'll go and rewrite him down here. So y equals x plus 5. And in the case of negative 3, y would be negative 3 plus 5, which then combines out to become a 2, which means when I plug in a negative 3, I get a 2 out. If I let x become negative 1, I get negative 1 plus 5, which means when I plug in a negative 1, I get out a 4. And those seem to be my points of intersection. But don't take my word for it. Let's go ahead and take a look at the calculator and see what he says. Or it. Calculators have no gender. So from here, x squared plus 5x plus 8. There's my parabola right there. And then I'm going to go ahead and graph x plus 5. So x plus 5. Okay, I'm looking at 2 intersection points right there. And I'll go and do my normal calculation operation. So analyze graph intersection, reasonable suspicion, boom, negative 3, 2. I think we're good there. And then, oops, not that, menu. Analyze graph intersection, lower bound, upper bound, negative 1, 4. I believe that was our answers. And there we have it. That pretty much is the lesson right there. So for the rest of the lesson, I'm just going to do a few examples. So let me clean up the board real quick, and I'll be back in a flash. And welcome back for the second example. We are dealing with another parabola versus a line. So let's see what happens when we set them equal to each other. So 2x squared plus 3x minus 9 equals x minus 5. So again, remember, when it comes to quadratics, we always set them equal to 0. So please don't do anything too fancy. I'm just going to move crud over. I'm moving these things over. That's all I'm doing. I'm getting rid of these guys. I end up with 2x squared plus 2x minus 4 equaling 0. Don't try to be a superhero on this one. GCF. Don't try to factor with a coefficient of 2 if you can factor it out. That gives us x squared plus x minus 2 equaling 0. And then you get 2, and this factor should be pretty easy. It should be x plus 2, x minus 1 equaling 0, so x equals negative 2 and positive 1. So again, just like the last example, we're dealing with a 2 intersection scenario here. So again, which one do I choose? The one that's going to make my life easier is easily the line. Don't try to be, don't try to be crazy here and try and be fancy and solve into the parabola. Before I solve for the line, I'm going to go and set up my coordinates. My coordinates are going to be negative 2 comma something and 1 comma something. I will find those comma somethings by plugging those numbers into the line. So y equals negative 2 minus 5 and y equals 1 minus 5. This guy's easier. I get a negative 4. This guy isn't too bad himself. -2 minus 5 is -7, and those are your two coordinates of intersection. Okay. So we've dealt with a couple of two intersection scenarios. Let's see about another one. In example 3 here, I'm going to say y equals x squared minus x minus 2. And then my other equation is going to be y equals x minus 6. So just like last time, I'm going to go and set them equal to each other. So x squared minus x minus 2 equals x minus 6. Let's go ahead and just, again, set these things equal to each other and set the piece equal to 0. So these guys are going to become x squared minus 2x. Looks like plus 4 is equal to 0. Okay, here's the thing, is that this thing isn't factorable, right? It's not factorable, which means I have two options. I can either use completing the square or the quadratic formula. I will lean towards completing the square because the middle term is even and my coefficient is 1. So how do I do that? Let's go and do a quick review of completing the square. I'm going to subtract 4 from either side. So x squared minus 2x, I'm going to leave myself space equaling -4. And now I'm going to add the box. On the right side, I'm going to add the box. I throw -1s inside the boxes. I get x minus 1 squared equals. Now this is the telltale sign of what's going to happen. I get a 1 here. -4 plus 1 is -3. Now, ordinarily, I would ask you to solve and put imaginary numbers in your answer. But remember, in the context of this problem, we are trying to find points of intersection. And the points of intersection will happen in the real coordinate plane. So because this will involve imaginary numbers, we can actually say, because we don't deal with imaginary intersections, we can just say no intersection points. No intersection points. Once we see the imaginary situation come up, there are no intersection points, and we can actually just move on from here. We're done with this problem. But before we move on, let me show you what this looks like in a graph, just to confirm that they will never touch each other. So let's go ahead and put these in. So x squared minus x minus 2, and then x minus 6. Where are you? X minus 6. No chance of making contact. That is why we ended up with that imaginary number in our solution when we tried to solve for x. So please keep that in mind. All right, so that is a no intersection situation right there. Okay, let's see here. Let's go and do another one. All right, we haven't dealt with a dual parabola yet. So let's go ahead and do that. So we're on example 4. We'll keep it pretty easy. Y equals -x squared versus y equals x squared plus 4x. I chose this example so that we could see a different type of factoring also, but again, like always, I'm going to set them equal to each other. In Integrated 3, you'll learn some more sophisticated techniques on how to do this also when you're dealing with different types of graphs. But for now, setting them equal to each other should be pretty standard for us. Okay, we haven't dealt with this in a long time, but please don't forget your basic factoring. This is going to require GCF. I'm going to factor out a 2x. On the inside, that gives me x plus 2, which means x will either equal 0 or -2. Alright, so keep that in mind, guys. Alright, so please don't forget your GCF and allow it to equal 0. So what are my coordinates? 0 comma something, -2 comma something. Well, how do I find those comma somethings? Well, I got to figure out which one of these is easiest to plug into. My gut's telling me the top. So y equals -0 squared. That's 0. Y equals, looks like negative. Now, here's where we got to be careful. -2 squared. Please be careful. These two negatives, they do not cancel each other out. This -2, because he's being squared entirely, he becomes 4, but he's actually negative because of order of operations. The negative applies after the fact. So -2, -4. So there are your solutions. And I believe that is enough examples for you guys. If you have any questions, as always, please leave comments or questions in the comments area, and I will see you in the next episode.